Let's start the session. Welcome everyone again. This is Mohamed Halabi. I'm Microsoft MVD and I'm the DevLifeStyle lead. So our website is devlifestyle.net, and you can contact me at my blog, the .nethub.blogspot.com, or at my email, I'm halabi@devlifestyle.net. Okay. So what is our agenda today? First of all, we're going to start discussing the claims-based architecture. This is, by the way, this is for any one of you who attended the last Microsoft Monday event. This is, I don't want to say continuation, but it's basically the same topic plus some additions. Don't worry though, if you're new to the topic, I will start from the very basics. So we're going to start explaining the claims-based architecture. What are claims-based applications? The technology independent, just explaining the architecture of claims-based access. Then we're going to jump to the Windows Identity Foundation, Microsoft toolkit, Microsoft DLLs called Windows Identity Foundation, and how it is used to achieve claims-based access. And we're going to look at 3 demos. We're going to see WIF, how it's working with ASP.NET, with ADFS 2.0, and with Windows Azure. So you will gonna find a lot of topics, a lot of concepts in this session that will be new to you. Again, don't worry. This is the aim of the presentation, to get you familiar with these concepts, and hopefully the demo packed session will be enough for you to get the grasp of these concepts. The best way to start the discussion is actually explaining the reason behind the claims-based access. So let's start by identifying what are the authentication problems that you face today when you are building your applications. Let's take a very basic scenario, a very common scenario. So let's say you have an ASP.NET application, and this ASP.NET application is contacting a user store. Let's say it's SQL Server, and this user store contains the users, right? This is a very, very typical approach, where you have your, let's say, usernames and passwords stored in SQL Server, and your ASP.NET application will authenticate against this SQL store. Now, let's say that you have new stores to trust. So, based on certain business requirements, first you were dealing only with users in SQL Server, then you are extending your application, and you have users inside Oracle, or let's say users inside Active Directory. Now, this is the first problem you have. You have new stores. What you're going to do? One more problem. Let's say you want to go with the trend these days, and you want to allow users coming from social providers, like, for example, live.com or Facebook or Google. So you want also to allow users coming from social providers to access your application. One more thing, which can even be more tough. You want to extend the authentication info. So let's say you have a login.aspx page, and basically you had username and password. So you ask users to enter username and password. Then, again, based on certain business requirements, then you want users also to supply their national ID. So you want to extend the authentication information. Great. So these are the problems. What is the common thing that you have to do when you face such situations, whether it's adding new stores or extending authentication info? The common thing that you face, the common problem that you face, is the amount of changes you have to do inside your ASP.NET application, right? So if you're following the current approach, if you're following the traditional authentication approach, there's no escape. There's no escaping from coming to your ASP.NET application, and whatever layer here you are using to manage authentication, it has to be changed. So you have to mess up with your application to handle changes in authentication logic. So I think we all agree that's far from being ideal, right? Okay, so what is the resolution? Still discussing this in a fairly high abstract level. What do we need? If we can ideally have something here, some layer. So I'm going to call till now I'm going to call it some layer, before starting, seeing the demos and the practical implementation. If we can have here some layer, and have this layer talking to whatever stores, and have this layer manage extending the authentication info. Now, by having this layer in the middle, your application will just talk to this layer without having to change. So, when you have changes for the authentication logic, when you have changes for the security information, for the adding new stores, deleting stores, extending authentication information, it's ideal if you can do the change in this layer and make your application resilient to these changes. Okay? Now, of course, one question might jump into your head. So, big deal. I'm going to have this layer. I'm going to change this layer, but I'm going to change anyway. Right? That's true. But the point is, this is a separate layer. This is a layer which is connected, which is not part of your application. So you might have, for example, some security developers, some security team handling this layer. The important thing is that your application, which handles your business, remains unchanged. So you can, for example, have a security team or a security architect or security developer handling this part, but your application remains unchanged. So that's the problem, and that's the resolution on a high abstraction level. Now let's see this in a more practical term. Please, I want to remind you that during while I'm explaining, if you have any questions, just shoot the question in the QA box, and I will answer it right away. Okay. Okay, so your application will actually take from this layer some information, okay, which is highlighted here. Again, what is this some information? Let's discuss it in detail. So this is what claims-based access is all about. Claims-based access is about allowing your application. Now we start talking concrete terms, okay? The previous one was a more generic, abstract level. Now we're going to start talking concrete terminologies. So this is your ASP.NET application. Your ASP.NET application will talk to something called Secure Token Service, SPS. The Secure Token Service is the one that will actually call the user stores. It will handle authentication against the user stores. I don't care what these user stores are. They can be SQL, Oracle, social identity providers like, for example, Facebook, Google, Active Directory. I really don't care. The important thing is that the SPS will do the magic in the middle, and the SPS will give my application back something called token. A token will contain a set of claims. Now, these claims can be anything your application wants. So it can be, for example, username, it can be email, it can be role, it can be, I don't know, position in the company, it can be national ID, it can be anything you want. The idea is that your application now handles this token, which contains these set of claims, regardless of the user store, regardless of how the authentication happens. You don't care. Now, how does this happen technically? You establish between your ASP.NET application and between your SPS, you establish something called WS Trust. The SPS itself, it implements the WS Federation protocol or WS Federation standard. Okay, so what is WS Trust? WS Trust is actually saying that my ASP.NET application trusts the SPS1, trust SPS1 and SPS2, let's say. Why is this? Because, for example, what if a hacker in the middle created SPS3 and fooled my application to trust SPS3 and started generating claims to my application, which my application trusts? This way, this hacker will get access to my application. Of course, this should not happen. So WS Trust says that my application will trust the following SPSs. Now, when we start seeing the demos, you will see what kind of SPSs we will deal with. We will deal with development SPSs, and I mean custom SPS. We will see the Windows Azure SPS, and we will see the Active Directory SPS. So bear with me for a moment now, and again focus on the concept. So that's WS Trust, okay? Another item which is WS Security, another standard which is or protocol which is WS Security, which handles communication between my application and the SPS. So, for example, when the SPS generates the token and sends it back to my application, I can configure it to be encrypted. Okay? The full cycle of handling the redirection and handling the full scenario, it's implemented via WS Federation. Okay? Now, where's WIF? You remember that I started my discussion with WIF. WIF, Windows Identity Foundation, is a set of extensions, set of HTTP modules that are installed on top of my ASP.NET application. And these modules handle the result coming back from the STS. And if these modules know that, for example, my user is not authenticated, so dump him back to the STS to authenticate. Okay. It will get more clear with time. I know it's a tough concept, but let's recap the concept we discussed till now. We have claims. So claims are a set of information required by my application to grant access. Claims are plugged inside security tokens. Claims-based access is the overall architecture for utilizing claims to access my application. You know trust and federation, again, WS trust and WS federation. You know the STS. STS is the secure token service, which actually handles the authentication for my application. And you know WIF, Windows Identity Foundation, which is a set of HTTP modules that are plugged inside my ASP.NET application. Great. So let's now jump to a real example. I hope this example will actually make the idea more clear and will actually show you how things will be implemented when we switch to the demos. Let's take a scenario. It's called passive client federation. Why it's called passive? Because when talking about federation and single sign-on, we have two scenarios, passive and active. When we say passive, I mean browser. We have another scenario which is called active, when the client is actually, for example, a web service. Okay. In this session, for simplicity, I'm not covering active client federation. I'm just covering passive client federation, but the idea is the same. Okay. So let's review this scenario. Let's say I have an ASP.NET application, and I have a user. He's browsing my application. Now, at one point, he wants to access a secure page. Let's say he wants to access a secured ASPX page, which has some secured information, which should not be disclosed to public. Okay, so the browser sends the request to my ASP.NET application. The WIF, which is missing from this diagram, but the WIF layer, which I talked about, set of HTTP modules, they know that, okay, wait a minute, this request is not authenticated. So WIF, okay, dumps this request back to the browser and tells the browser, wait a minute, your request is not authenticated. And it sends to the browser back the URL of the STS that my application trusts. Okay? So my browser now knows that in step 3, it has first to authenticate against STS. Great. Step 3, the browser sends the request to the STS. In step 4, STS takes the authentication data. For example, the STS will show the browser, will show the client, let's say a username password page, depending on how the STS is configured to authenticate the user. The user will enter the authentication information, let's say username password. STS will take this information, go to the user store, be it SQL, again, SQL, Active Directory, Oracle, I don't care. It will do the authentication, whatever authentication logic is required. The STS will do. Now let's say the user is authenticated. The STS will send what? Will send a token with a set of claims inside. So we'll send the token back to the browser. The browser now has the token. It sends it to the application, and the application will grant access. Why? Because my application trusts the STS. That's a lot, huh? Okay, so again, that's a lot of concepts. So again, if you have any questions, I know it's a tough topic. If you have any questions, please shoot them. But this actually covers the full scenario. Okay, so I'll just recap. The browser sends the request to my application. Windows Identity Foundation sitting on top of my application detects that the request is not authenticated, but my application now has exported the authentication logic to the STS. So the browser sends the request to the STS instead. The STS actually does the authentication. It generates a token containing the set of claims that my application requires. The browser now sends the token with the claims back to my application, and because my application is configured via WS Trust, is configured to trust this certain STS, the request will get access. The request will get authenticated. And the user now will be able to browse my application. At this moment, my application will generate a cookie, will generate a session cookie, dump it into the browser, and from the second request on, the browser will actually use this cookie to browse my application without having to go through this full cycle again. Now this full redirection, this full pattern, if I might say, is implemented via WS Federation. Okay. So I hope this clears the idea of federation, clears the idea of some vague concepts like WS Trust, WS Federation, claims, and STS. So now actually, we can jump to our first demo. This scenario that I showed you here, I will show you the concrete implementation of this scenario using ASP.NET, okay, using ASP.NET and Windows Identity Foundation. And we'll see how it's easy to spin up an application and configure it for passive federation. So I will switch to Visual Studio. And waiting Visual Studio to spin up. I will actually first start by creating a blank ASP.NET website. So just spin up a new website, select the C# templates, that's my ASP.NET website, okay. Call it whatever, so it will be called website 12. It's a little bit slow because I'm running also a set of virtual machines, and these virtual machines will be included in the demo to show you Active Directory Federation services. So because of this, I'm actually, my machine is starving because of the RAMs. Anyway. It's taking too much. Let me try to close something here. Okay, finally, I have the website. Okay, what I want to show you next is how to add WIF support on top of my website. Recall that I told you that WIF installs a set of extensions, the HTTP modules, on top of my website to actually intercept the request, to know that it's not authenticated, and then its other responsibility is to handle the token and the claims coming back from my SPS. Oh. Oh my God. Okay. That's embarrassing. Still waiting for my super fast Visual Studio. Okay. So I will right click my website and I will choose add SPS reference. Now what I'm doing now, I'm using the first demo. I will show you how to develop against a development type SPS. Okay. So the first screen, it's asking me about my application. Okay, I'm selecting my current application. Forget this one. Next. It will warn me that my application is not hosted on top of HTTPS. I don't care. Now here I have three options. I have the option of no SPS. Forget about this. It's not interesting. I have the option to create a new SPS project, and this is ideal for development purposes. And the other option is to use an existing SPS. Now, keep in mind this other option, which is use an existing SPS, because I will use it in the other two demos. In this first demo, I will create a new SPS project, which will be ideal for development purposes. Finish, and the Federation Utility Wizard will actually do some configuration changes for my applications. It will add some references, some DLL references to my application. Will register the HTTP modules I told you about. It's working, and I should get the notification that it's done. I'm not sure why this is happening, but my RAM and my CPU are normal. Anyway. Okay. So the SPS is generated, and as you can see, it's called website 12 underscore SPS. And now look what's happening. It's this SPS project, it contains the login page. Okay. So the login page is no more inside my main website. The login page is inside the SPS application. And it has done some configuration changes for my application, most notably the Federation metadata XML file. So this is the policy. This is the policy required by my application to do the Federation scenario. And it has done some configuration changes to the web.config file. The most important changes are the followings. So recall that I told you that it registers two HTTP modules to handle the Federation stuff. These are the HTTP modules. One module to handle to intercept requests and know that, okay, these requests are not authenticated, so redirect back to the SPS. And the other module is to, once it gets back the tokens, it takes the tokens and the claims, and it knows how to populate certain classes, to populate the user identity, and specifically to populate the I identity and the I principal interface. And finally, it has the issuer, which is the SPS. By issuer, it means the identity provider, the ID, the issuer that actually presents or issues the tokens and the claims. Let's see how the scenario will now shape. I will browse for my application, as you would usually do. Now, look at the URL. It's localhost website 12. Automatically, it will be redirected to the SPS. Recall back the slide where I showed you the scenario. What's happening now is that I'm requesting the application. WIF is detecting that the request is not authenticated, and the request, and I'm now being, as a client, as a passive client, I'm being redirected to the SPS. This is the page of the SPS, the default page. Okay, I will log in with whatever. Of course, now it's hard-coded. I'm not actually being authenticated against any store. So I will click submit. And I'm taken back to my application. So the full scenario that I explained, it's now implemented. Okay, I'm authenticated by the SPS, not by my application. And the SPS has actually generated a set of tokens and claims and presented this token and these claims to my application. Okay. Now let's see some interesting stuff inside this application. Although now my authentication is delegated to the SPS, you can still access the same authentication information you could usually do. For example, I don't want to write this code, so you know this familiar code, page.user.identity.name, or for example, page.user.isEnroll, and I'm checking the role manager. Okay, and let me loop through all the claims. All the claims generated by the SPS. Let me just resolve the references, and in a moment I will explain what's going here. I will just take you for the SPS, because I promised you that you can create whatever claims you want. As you can see here, the SPS by default, the default template, it's hard coding 2 claims, right? It's hard coding one claim which is of type name, and another claim which is of type role. You might, for example, add another claim, and I will select the claim type which is email, and let's say it's manager@demo.com, whatever. I will save this. I will go to my application, and I will set a breakpoint here. Let's run. Okay, add the debugger information. Okay. Now, check the user. The user, this is whatever, Adam Carter, which is the user that I used to log in. Now, the question is, how does this information, the page.user.identity.name, how is it populated? Although my authentication now, it's not Forms authentication anymore, it's not Windows authentication, my authentication is handled by the SPS. So how is this user populated? The answer is WIF. So WIF HTTP module does that. Similarly, isEnroll true, which is the role manager, because it came as a claim of type manager. So again, WIF handles that. Another thing, which is, let us watch here, for example, the claim. Once I start looping through the claims, you can check the claims that are generated by my SPS. So first one, which is claim of type name, hit F5. Second one is the claim of type role, which has the value manager. Okay, and that's why, because I didn't refresh the session. Let me try it again, because you might be wondering, where is the claim email? Let's do the scenario quickly again. Log in through the SPS, going back to my application. This is response to the redirect issue, forget about it. So let's loop through the claims. Again, this is the first claim, which is name. Second claim, which is role. And now you can see the third claim, which is the email address. Okay, so it's really that easy. So now my application, instead of dealing with the authentication logic, it's only dealing with the claims. Great. Great so far. Going back to these slides. So now the first question that should pop up into your head, so will I build my own SPS? Most probably not. Building an SPS it's not a simple business, it's not a simple task. It's a very tough task. You have to know a lot about a lot of security concepts. You know, the WS Trust, the WS Federation, the WS Security. It's really very rare, if ever, that you have to write your own SPS. You will usually utilize some of the available SPSs. Now, in the next two demos, I will show you two out-of-the-box SPSs. I will start with the Active Directory Federation service, ADFS 2.0. This is the SPS built on top of Active Directory. And this is the SPS that you can utilize to authenticate against, as you will see in this demo, against Active Directory. Okay? So I will take you to my virtual machines. And I have here a lab set up. First machine is DC1, which is my domain controller. And this is the second machine. It's joined to my domain. The domain is called DC1. Okay. What I want to show you is this is ADFS 2.0 management console. Again, ADFS is nothing but an SPS, at least in this demo. Okay, it has more roles to play, but in my case, I'm showing it as an SPS. And here I'm defining a set of relying party trusts. So I'm telling my SPS to trust the following relying parties. By relying parties, I simply mean my applications. Like for example, in my previous scenario, my ASP.NET application, in the terminology, it's called a relying party. The SPS, it's called an IP, an identity provider. So here I have already configured something called the display name is called claim app2, and the identifier is whatever, the URL of my application in my second machine. So let me show you the configuration for this relying party. Okay, let me show you some interesting stuff here. So this is the identifier, the display name, and this is the relying party address. Recall this address, you will see it when I switch back to the second machine to establish, to kick off the federation scenario. And these are the accepted claims. These are the claims accepted by my application. Okay. What's next? Yes, the claim rules. This is very interesting stuff. So here I have defined a set of claim rules. Like for example, this claim rule is called UPN. This rule basically it's saying that once my request is authenticated, the ADFS 2.0, again, the SPS, will actually extract the user principal name from Active Directory and will pass it to my application as a claim. So again, the scenario is, I will explain the scenario and then I will show it to you. The scenario is, I will browse to my ASP.NET application. My ASP.NET application is configured to talk to an SPS. Now the SPS itself, which is based on ADFS 2.0, is configured to authenticate against Active Directory. So when I enter my username password and click sign in, ADFS 2.0 will authenticate against Active Directory, will take my user principal name from Active Directory and will pass it as a claim to my application. Okay, so that's the configuration I wanted to show you. Final configuration, which are the set of certificates I'm using. I'm using one certificate for service communication, for encrypting the full communication, another one for token signing, and another one for token decryption. Okay, so let me go back to my application. Sorry, to my second, let me call it to my client machine. That one was the domain controller machine. I will quickly show you the web.config for my application. I will not open it in Visual Studio because I know it will hang. So this is the federation metadata location. It's pointing to what? It's pointing to, okay, you guessed it. That's my STS in my DC1 machine. So DC1.lab1.net, Federation metadata. You can guarantee this here in the issuer tag, issuer attribute, sorry. Again, in my issuer attribute, it's pointing to my STS, which is DC1.lab1.net. Okay, so this is the STS that will generate the token for my application. Let's try this. Let's browse. To my application. And I will actually try to browse for my local application. So can you see here the URL? That's lab1 win 2008 R2, the name of the machine, .lab1.net. That's the local machine. Okay, I can't use localhost. And that's my application. Click enter. And again, the request is not authenticated. WIF detects that. WIF forces my browser to go through the STS. However, this time it's not a development STS. It's the ADFS STS, the production STS, if you will. So I'm being redirected to the STS. Hopefully it will happen soon. Okay, now examine what's happening. Can you see this Windows security alert? And the server is what? The server is dc1.lab1.net. That's the location of my STS, right? Of my Active Directory Federation service. In the previous example, I was using forms authentication. In this example, I'm using authentication against Active Directory. So as you can see, I presented with the box to present my Active Directory username password. In this case, I will log in with my administrator account. Hit OK. The request now goes to STS. STS validates my authentication against Active Directory. And if you recall the claims rule, it gives back these claims to my application. So now I'm back inside my application. Okay. And you remember the claim rule I showed you about, which is the user principal name. Here is the claim rule. So these are the claims generated by my STS. And that one is the claim rule I showed you about. So this is administrator at lab1.net. This is the UPN name from Active Directory. Okay, good. So that's two demos for now. One demo using a development STS, another demo using the Active Directory Federation Services STS. So this brings me to the third and final demo. So what about the cloud? So nowadays, any demo it will not complete without cloud, right? So even in the cloud, you have another ready-made STS, which is the Azure Access Control Service. So the concept is the same. You have your application. You're delegating access to another STS. However, this time, it's not a development STS. It's not Active Directory. You're delegating your authentication to the cloud. And in the demo I will show you, the identity providers will actually be social identity providers. It will be like Facebook, Google, whatever. Okay? So the moral of the story, you have another STS sitting on the cloud, which is the Windows Azure Access Control Service. ACS for short. Okay. Let me close these virtual machines. Okay. So I will, no, it's called MVP. So I will browse for my online Azure account to the access control service. That's my account on Windows Azure. Okay, I will start from from scratch. Just give me a moment to clean this up. I want to clean the previous demo. Okay, now let's start. This is ACS, management location, okay, management application. And here I have already configured two identity providers. These are the out-of-the-box identity providers. I'm going to show you Google and Windows Live ID. Okay, so these guys are providers which I want my application to trust. So the end result, I want a user coming from Google to authenticate against my application. Similarly, I want a user coming from Windows Live ID to authenticate against my application. So those are the identity providers. The relying party applications, again, recall by relying party, I mean the application accepting the tokens. I mean the application, which means the application delegating the authentication to the SPS. Now, I will add a new relying party, and I can write localhost. So HTTP localhost. The URL of the application itself, I know that I will call my application. I will call it DevLifeStyle, whatever. DevLifeStyle relying party. Okay, so it's DLSRP. Let me copy this. And finally, I want to create a new role group. There are some options here like SAML tokens. I don't want to get into this because I want to keep the session focused. For now, know that the tokens that I'm talking about, the token containing the claims, it's in something called SAML token. It's a SAML token. Okay, SAML is one of the options. There are other options, but anyway, let's move forward now. Okay, whatever. Display name. Great. So I have configured my application, my relying party application. Finally, I will go to the rule group and I will edit the rule group for DLS and I will generate again the default. And by the defaults I have generated, basically what I'm saying that my application will handle will accept these claims. Okay, so it will accept token containing these claims. Let's go back to Visual Studio and let me create a new website again. I hope it will be faster this time. ASP.NET website. Remember that I have to call it DLSRP because that's the name I have given to my relying party application. So wait for my application for my website to be created. Good, it's faster this time. Now, right click, add SPS reference, and keep the default options. Again, no HTTPS, fine. So I'm back into this window. Remember now recall the options. The first time I created a new SPS project. This time I will actually use an existing SPS. So what is the URL for this SPS? Go back to the portal, management portal, and go to application integration. And the access control service has actually published its own WS Federation metadata file for me to use. Okay, so I will copy this and go back and paste it here. So now I'm using an existing SPS which has its own Federation metadata. Recall that in the first demo, I created a new SPS project. That was a development SPS. So a default Federation metadata were generated. In the second demo, the one about the ADFS, recall again, I used the Federation metadata coming from ADFS, which is this one. In the third demo, I'm using the Federation metadata coming from the cloud. Okay, so hit next. I will accept some default security options. Disable certificate chain validation, fine. I'm using self-signed certificates. No encryption, no problem. Fine, accept the claims and hit finish. It's done. And now see how it's easy, how easy it is. I will browse my application. Same scenario. WIF will detect I'm not authenticated. I will be redirected to the STS. However, this time it's not a development STS. It's even not ADFS. It's the cloud. So I'm taken to the access control service, Windows Azure, okay? And I will have two options. I will have option to authenticate against the Google or against Live ID, whatever. I will authenticate against Windows Live ID and enter my account. Sign in, and I'm back to my localhost application, and I'm logged in. Okay, of course I can repeat the same scenario, doing this using Google, for example. Same idea. Okay, since I'm about to finish and I still have some time, I want to show you another benefit of using this federation. Let me go back to the website, this website 12, which is authenticated against the local STS, remember? Okay, great. Let me create a new website. This website is 13. And what I want to show you, single sign-on. And how it is easy to establish single sign-on by having two websites, I mean two relying parties, trusting the same STS. So this website 13, once again to my favorite add STS reference, I will use an existing STS. However, what I will do now is that I will use the same development STS, which is website 12_STS. Go into the Federation metadata, getting this, next, okay. Okay, so now what happened? I have a new website, website 13. It's trusting the same STS that website 12 is trusting. Okay, so let me go through the authentication of website 12. I already did it. Let me do it again. Login, of course, again, remember that I can write here anything I want. For now, it's hard-coded. Okay, now let me take this, open a new tab, and I will browse to website 13, and as you can see, I'm already authenticated. Because website 13 and website 12 already trust the same STS, and because website 12 is already authenticated, I was able to do some sort of, not some sort actually, I was able to do single sign-on between two applications, because both applications trust the same STS. Okay, great. So this actually wraps the session. I hope you enjoyed it. I know a lot of concepts. It's a little bit of a complicated session, but I tried as much as I can to keep it simple. I hope you get the idea behind it. Your next step is to start playing with these tools. Start, using the STS Federation utility. Start playing with the tools. There's the WIF SDK you can download and you can play with it. And you can read more about the claims-based authentication, claims-based architectures. If you have any questions about this topic, if you want any follow-up, remember that you can contact me at my email or at my blog. So this wraps up my session. If you don't have any questions, I will end here, and in another 5 minutes, we will have Jerry talking about SharePoint. So 5 more minutes and the next session will continue. Thank you.